Question number 7 is a real tricky looking problem. You've got a nice diagram here. It's a rectangle A, B, C and D, and that represents a park, this rectangle. The lines show all the paths in the park, so A to B is a path, B to C is a path, etc. The circular path is in the centre of the rectangle, as you can see in the diagram, and it has a diameter of 10 meters. Now, that's not marked on the diagram. I am going to first of all mark that on the diagram roughly. The diameter is obviously the distance from one side of the circle to the other going through the centre of the circle. That is 10 meters. And we are asked to calculate the shortest distance from A to C across the park using only the path shown. Now, we can get from A to C by going A to B and B to C. Now, obviously, that's not going to be the answer. We could easily work out that it would be 40 plus 60 meters, given that it's a rectangle, so therefore that side's 40 meters as well. That's 60 meters. If we just added those numbers together, we'd get a way of getting there. 6-mark question, so it's not going to be as simple as that. The shortest way across the park is obviously going to be through A, around this semicircular path, and back onto the straight path and across to C. So this is a combination of two separate skills, this question. We're told that it's a rectangle for a reason in the question. It has a right angle here, okay, and that's an important part of understanding this question. What we should be looking at here, if we've joined this circle here as well as we can to these two black lines that we've got for A to C, we've got a right angled triangle, okay? Now the first thing you should be thinking about when you see a right angled triangle is, I don't have that length, I want that length, I'm going to use Pythagoras' theorem. Now this is a proper calculator question, okay? We need to work out what this distance is, and then we're going to have to play around with things because we need to take away that 10 meters and add this distance on here. So it's also a circumference of circle question, not just a circle but a circumference of this semicircle that we have here. Okay, so plenty to do. Let's get started with the question. What we've got to do first is use Pythagoras, and to do that we can, on this rubbish calculator, let's do it the long way. We've got a squared plus b squared equals c squared. That's first of all a bit of knowledge you have to have in your head. You have to know that it's Pythagoras' theorem, not very difficult to remember. Let's label our sides of our triangle and let's draw it again roughly. Here we have A, B and C. C being the one that's opposite the right angle, the longest side, the hypotenuse. A and B, doesn't matter which one's A and B. So I'm going to put in the numbers that I have here. I've got 60 is my A, 60, and 40 is my B in meters. So I'm going to use those numbers. 60 squared plus 40 squared equals, and then we're going to find out that C squared is equal to something. So let's use our calculator. 60 squared plus 40 squared equals 5,200. At the moment we know that C squared is equal to 5,200. We don't want to know what C squared is, we want to know what C is, the length of C. So we're going to square root both of those things and we're going to get C equals the square root of, and if we just press the square root button, hopefully it should find out the answer for us. We've got 72.111, lots of numbers afterwards, so dot 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 dot. That is the length from A to C if we were going to go through the centre of that circle, which we can't because it's not a path. So at the moment we have to think about, right, well, we have to take away that 10 meters. We're going to take away that 10 meters because we're not going to be walking over that distance. So I'm going to do 72.111 blah 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 minus 10. That's going to give me 62.111 blah 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 meters. So what we need to do is use the circumference of circle formula to calculate this distance around the semicircular part of the path, and the formula that you need to remember here is pi times diameter. Circumference is equal to pi times diameter. So if we use that formula for the second part of the question, we're going to substitute in the number pi. Well, see if my calculator's got a pi button. It has. So I'm going to clear that. Ultimately, you would use your scientific calculator and keep the numbers on the screen, what have you. But this is a rubbish one. So we're going to go with pi multiplied by 10. Pi multiplied by 10 is equal to that number, 31.14, etc. That is the circumference of that particular circle. Well, we don't want the whole circumference, we only want half of it, so we're going to divide that by 2, and that will give us 15.7079, so 15.7079, etc. That number is the distance from here to here around this semicircular path. We can now add that on to the 62.111. I'm going to do that on my calculator, plus 62.111. Ideally, you'd use all the digits, not round it off at any point here. I've just used that because I had to. That's given us the answer of 77.81 something, 81896, 1896, blah, 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 blah. Let's now round that answer because we don't want all those numbers after the decimal place. Let's round it to 77.8. It doesn't give us a degree of accuracy to be specific to, so we're going to go with 77.8 meters.